Hello everyone, welcome to the course of Fundamentals of IoT. In today's class, we are going to learn about IoT communication protocols. First, we need to know what is a protocol. So protocol is a set of rules and regulations in order to perform a particular task or do a job. Okay. Suppose with respect to this IoT only, in order to have a communication between, it can be a wired or wireless communication using an internet. In order to have that particular communication, we need to follow some set of protocols and their rules. Okay. So what are all those protocols? What are their rules and regulations? How they behave? Okay. So how the data is transferred, everything we are going to see in this particular IoT communication protocol. So IoT communication protocols form the backbone of IoT system. And not only that, it enables network connectivity, coupling to many applications. So mostly the communication protocols in the IoT allow devices to exchange data over the network. So it can be basically an internet. So there are several protocols like link layer, network layer, transport layer, application layer. Okay. These are the most famously used protocols or the layer models, okay, for the IoT communication. These protocols generally they are maintained for the data exchange format, data encoding, addressing schemes, okay, and for routing of packets from source to destination. Routing means sending the data in the form of packets from source to destination, okay. So, and not only that, the other functions of a protocol also include sequence control, data sequence control, flow control of the data, and if at all any data has been lost, okay, retransmission of lost packets also be done with the help of these kind of IoT protocols. See, if you see the overall diagram of an IoT protocols, so each layer will be containing, okay, several services. Okay, so in the screen we have application layer, transport layer, network layer, as well as link layer. So application layer provides services like HTTP, COAP, WebSockets, MQTT, XMPP, DDS, AMQP. Okay. So I will be explaining you each and everything and along with its observation and the job it does. Okay. Coming to the transport layer, it has the most famous services, TCP as well as UDP services. Okay. So all these are generally protocols only. So coming to the network layer, most of the people will be, whoever is using the internet are well known with this particular network layer protocols, IPv4, IPv6 and 6 LO WPAN protocol, okay, and services. And coming to the link layer services, we have like wired and wireless, like 802.3 Ethernet, 802.16 WiMAX, 802.11 Wi-Fi, 802.15.4 LRWPAN, and also 2G, 3G, LTE cellular services, okay. So all these things we are going to see one by one. So let's see first application layer. So application layer protocols generally defines how the application interface with the lower layer protocols to send the data over the network. So application layer in the sense, we can generally call it as apps or the websites, okay, or the browsers, okay. So whatever we see with our eyes graphically, those can be considered as the application layer in order to user can easily operate them or use them for the data transfer. So this particular protocol is very much used to send the data over the network, okay. So mostly in application layers, port numbers are used for application addressing. So whatever the data you are sending using an application, okay. So based on the port, each and every data transmission will be having through a machine will be having a port number. Through that port number only, we are able to send and receive the data, okay. So application layer protocols enable process to process connection using the ports. So two machines are there, let us say, okay. One machine is transmitting the signal with some data and another machine is receiving. Similarly, this particular machine, again, the second machine is again retransmitting some sort of message, and the first machine is receiving it. So what's happening? There are some ports enabled between these two machines, such that through the port numbers, they are able to exchange their data. Okay, it's a kind of chat, or it can be an audio, or it can be a video call. It can be anything. Okay, like a Zoom meeting or anything. Okay. Now, in the application layer, we have several protocols or the services. Let's see one by one. Quick overview. HTTP. First comes the HTTP. HTTP is nothing but the hypertext transfer protocol. Okay, it is one of the famous application layer protocol, which is the foundation of World Wide Web. www. If you go to a Google Chrome browsing or any kind of browsing, generally we see with World Wide Web, www, with some website names, right? Okay. And in the above link, you can also observe http:/:. You are going to observe, you will be observing all those things, right? So it's a protocol in order to send or transmit or receive the data through a World Wide Web foundation. Okay. So generally what this protocol do means, it's a request response, okay, where client sends a request to the server using the HTTP commands. So HTTP includes most of the commands like get, put, post, delete, head, trace, options, etc. Okay. So this is not comments, it is commands. COMMANDS, HTTP commands. Okay. Please ignore it. Now coming to the next service, we have COAP, Constrained Application Protocol. It is also a part of application layer protocol. So this is for the machine-to-machine applications. So in order to have a data transfer over the network between two machines. Okay. So this particular protocol is majorly used. Next comes the Websockets. So Websocket protocol allows full duplex communication over a single socket. Using a single socket only, a full duplex communication, transmission and reception of the signal can be done at a time. Okay, over a single socket connection, and the communication, sending the messages between the client and server, can be done simultaneously. And next comes the MQTT, Message Queue Telemetry Transport Protocol. So it is a very lightweight messaging protocol based on the publish, subscribe model. Okay. So this MQTT also uses a client-server architecture where client connects to the server and publishes the messages, okay, based on the topics on the server. Okay. So it's a kind of publish subscribe model. Okay. So whatever the data we are sending using this MQTT protocol, that will be published, those messages will be published on this particular server based on the topics. Okay. Now, XMPP. Okay. So this XMPP is nothing but Extensible Messaging and Presence Protocol. XMPP, it's a protocol for real-time communication. Okay. Like high performance applications like messaging, gaming, chat rooms, voice and video calls, those kind of things, these extensible messaging and present protocols are very much used. They should be having a communication in real time. Okay, so there should not be any kind of delay with respect to this particular data conversation. Okay. Next comes DDS, Data Distribution Service. Okay, so it is a data-centric middleware standard for device-to-device or machine-to-machine communication. So between the device-to-device or a machine-to-machine, the communication need to be very much data-centric. Okay, so it also provides the quality of service, control, as well as configurable reliability. Okay, and coming to the AMQP. Okay, this service is a protocol with respect to advanced message queuing protocol. So it is somewhat like a protocol applied for the business messaging. So AMQP supports both point-to-point publishers as well as subscriber model, like with the help of routing as well as queuing. Okay, so routing and queuing of the data can be done, and whatever they search for a particular topic, the message will be displayed, okay, in the server based on this particular requirement, and that too, this is specially for a business kind of messaging. Okay, this protocol is used. Next comes the transport layer. Okay, so the transport layer protocol is nothing but the end-to-end message transfer capability independent of the underlying network. Okay, irrespective of the network. Okay, so it provides end-to-end message transfer. Okay, so this will be having majorly two. One is transmission control protocol. Another one is UDP, user datagram protocol. Okay, so transmission control protocol is most widely used the transport layer protocol. So majorly used for the web browsers like HTTP, okay, and for email applications with the help of a protocol called SMTP, and for the file transfer protocols FTP, okay. And coming to the UDP, user datagram protocol, it is majorly considered as a connectionless protocol, okay. So it is majorly used for the time sensitive applications and have very small data units to exchange. Okay, so the data also will be small and also useful for the time sensitive applications. Okay, and there's no much complex regarding the connection setup. Okay, it's a kind of connectionless protocol. Okay, it will be time sensitive as well as very small data of units will be available to exchange, or exchange of very small data units will be happening regularly. Okay. Now coming to the network and internet or internet layer, these things. So the network layers or the internet layers are responsible for the sending IP datagrams. So each and every process what's happening in the internet or the network layers will be with the help of an IP address, right? Okay. So once we are transmitting a data through source to the destination using these networks, IP datagram plays a major role. Okay. So this layer performs host addressing as well as packet routing. Okay. Not only IP datagrams, along with that, it also performs addressing the host. Okay. And we can also route the data packets wherever it want to go. Okay. So this particular datagram contains source and destination addresses, which are used to route them from source to destination across multiple networks. So each and every data from where to where it is going. Okay, each and every, so source data will be also there, and destination address will also will be there. With the help of this particular source and destination address, the data can be easily transferred even though there are multiple network connections. Now among these we have IPv4, IPv6 and 6 LoWPAN. Okay, so coming to IPv4, it's a most famous version. It's in the internet. So Internet Protocol version 4, it is the most deployed internet protocol which is used to identify the devices on a network. Okay, so it is mostly based on the hierarchical based, okay, with respect to the addressing schemes. Okay, mostly all the internet facilities nowadays are using the Internet Protocol IPv4 versions to identify a particular network or to use an internet. When coming to the IPv6, it's an successor of IPv4. Okay, it is the newest version of the Internet Protocol. Okay, than compared to the IPv4. Okay, it will be having some advanced versions as well. Okay, and coming to the 6 LoWPAN. Okay, it's a kind of IPv6 over low power wireless personal area networks. Okay, so it will be having an IP protocol, okay, especially designed for the IoT devices like low power devices which have limited processing capabilities. So suppose a device will be having a frequency range of 2.4 gigahertz, and it will be providing a data transfer rate between 250 kb per second. Okay, it's a very small device which will be having a small range of frequency, which is connected over the internet and used for IoT applications. This is one of the protocol is used for the low power devices with less frequency and less data transfer. And coming to the next layer, link layer. Okay, so the link layer protocols determines how the data is physically sent over the networks or physical layer or the medium. Suppose we need to send a data. So it sometimes it can be an internet cable, sometimes it can be a wireless Wi-Fi router. Okay, so it determines how the data is physically sent, means it may be through a copper wire, coaxial wire, or a wireless radio waves. Okay, so link layer determines how the packets are coded, signaled by the hardware device over medium which the host is attached. Okay, how the data is transferred through a particular cable. So if at all we are using a cable to transmit the data, if at all we are using a wireless medium to transmit the data, we need to follow some rules and regulations like protocols. Okay, so coming to this protocols, we have a protocol called or standard called 802.3 Ethernet protocol. Okay, so this particular IEEE 802.3 is a collection of wired Ethernet standards. So generally we plug an Ethernet cable for the PCs or for the internets, right? In IoT devices also, we may use for this particular Ethernet devices within IEEE 802.3 standards. Okay, so but these standards provide data rates from 10 MB per second to the 40 GB per second, and also sometimes higher. Okay, so Ethernet also will provide, though it's a wired connection, Ethernet will provide a high data transfer. Coming to the Wi-Fi router, okay, so it follows 802.11 protocol, IEEE 802.11. It's a general wireless local area network. Best example is our router. Okay, so these provide a data rate from 1 MB per second to 6.75 GB per second, and sometimes higher also. So these Wi-Fi routers or the Wi-Fi devices which follows 802.11 protocol varies design to design or the standards to standards or the frequency. Okay, so we have 5 gigahertz and we have 2.4 gigahertz. Okay, all these routers are very much standards. According to that, the data transfer also differs. Okay, and coming to the 802.16 WiMAX protocol standard, okay, it's a collection of wireless broadband standards, which is also called as WiMAX. Okay, so whenever several wireless broadbands are brought together and connected together to perform a particular application, IoT applications, then we need to follow a protocol called 802.16 WiMAX. Okay, so WiMAX standards provide data rate from 1.5 MB per second to 1 GB per second. And the last one is like 802.15.4 LRWPAN. So it's an protocol. It is used. It is an low rate wireless personal area network. Okay, so generally a wireless communication module is used for IoT device like Zigbee's. Okay, it's a modules, LoRa, Zigbee, RF, and all those things. Okay, so for that 802.15.4 LRWPAN, which is a low rate wireless personal area networks, these protocols are used. Okay, and these standards form the basic specifications for the communication protocol, like as I have already said, like modules like Zigbee and all those things. And the data rate is also very, very less. Okay, so the data rate varies from 40 KB per second to 250 KB per second. Okay, this is what all the link layer, network or internet layer, transport layer, okay, and application layer, okay, varies. Okay, and in the link layer we also have a cellular protocol which will be having a second generation, third generation LTE or cellular kind of layer through which we can use data. Okay, so the mobile phones or the smartphones where we are using data, right? 2G, 3G, 4G. Okay, that also falls under the link layer using a SIM card. Okay, like a subscriber identity module. In that only a data service also integrated with the help of mobile cell sites. Okay, so all these layers, application layer, transport layer, network layer, link layer, all these layers are helps in developing the IoT devices for monitoring as well as controlling the IoT devices for various applications.